children, welcome to Veena's Chemistry Talks. In today's video, we are discussing about balancing redox reactions using oxidation number method. So here we have a skeletal chemical equation, that is Cr2O72 minus, that is dichromate ion, plus sulfide ion SO32 minus, giving chromium 3 ion and sulfate ion. Remember, this is sulfide and this is sulfate. Now, this is an ionic equation. We need to balance it using oxidation number method. For that, we need to follow certain steps. The first step is to write the equation correctly, that we have already done. Next step is assign oxidation number to all the atoms. So we can assign the oxidation number and try to identify the elements which undergo a change in their oxidation numbers. So I hope everybody knows how to assign oxidation numbers. Here, all the species are ions. So we know that for ions, the algebraic sum of the oxidation number of all the elements in that polyatomic ion will be equal to the charge of that ion. First, we can take the dichromate ion. The dichromate ion has a charge -2. Now we know the charge of oxygen, the oxidation number of oxygen. We know that the valence of oxygen is -2. The charge is -2. Usually in all the compounds, oxygen have an oxidation number -2. Now the next step is to find the oxidation number of chromium. For that we need to find the algebraic sum. Here two chromium atoms are there, so we can write it as let the oxidation number of chromium be x. So here two chromium atoms are there. So the total oxidation number for chromium will be 2x. Plus there are 7 oxygen atoms and its oxidation number is -2. So 7 2s are -14 is equal to the algebraic sum of these elements. The oxidation number will be equal to the charge, that is -2. So 2x is equal to -2 minus -14. So that is equal to -2 plus 14, that is equal to 12. X is equal to 12 divided by 2, that is +6. Okay, so chromium, the oxidation number will be +6. Now let's find out the oxidation number of sulfur in the sulfide ion. As usual, the oxidation number of oxygen will be -2. Now what will be the oxidation number of sulfur? Let's calculate. Here, let the oxidation number of sulfur be x. X plus, there are 3 oxygen atoms, so 3 into -2 -6 will be equal to -2, the charge of the ion. -2. Now x is equal to -2 minus -6, that is -2 plus 6, that is equal to +4. So the oxidation number of sulfur is +4. So the reactant side is over. Now let's calculate the oxidation number of chromium here. This is already chromium 3 plus ion. For chromium 3 plus ion, the oxidation number is its charge, that is +3. Now comes to sulfate ion. Oxygen, we know its oxidation number is -2. Now for sulfur, let's follow the same thing. X, let X be the oxidation number of sulfur. X plus 4 into -2 minus 8 is equal to -2. So X is equal to -2 plus 8, that is equal to +6. So So the second step is over. We have assigned oxidation numbers. Have a look at it. Identify the elements which undergo a change in their oxidation number. So first take chromium. Here on the reactant side, its oxidation number is +6. On the product side, the oxidation number is +3. So what happens to chromium? The oxidation number decreases from +6 to +3. Here oxidation number decreases. When oxidation number decreases, chromium undergoes reduction. So it undergoes reduction. Now what about sulfur? From +4, sulfur's oxidation number changes to +6. +4 to +6. That means oxidation number increases. When oxidation number increases, we can say the species have undergone oxidation. So sulfur is oxidized. So if you look at oxygen, it's as usual -2 everywhere. Its oxidation number doesn't change. Now let's balance the equation. So before balancing the equation, we have identified the elements that have undergone a change in their oxidation number. They are chromium and sulfur. Okay. Now what we have to find out is to balance the number of chromium and sulfur on the reactant side, on the product side, as well as on the reactant side. On the reactant side, Cr2 means there are 2 chromium atoms. On the product side, there is only 1 chromium atom. Balance it. So what should we do? Put 2 here. Then here also 2, here also 2. What about sulfur? Sulfur here 1 sulfur, here also 1 sulfur atom. So it is already balanced. Now let's go to the next step. The next step is to find or calculate the total change in the oxidation number of chromium and sulfur. They are the elements which undergo a change in their oxidation number. Okay, so find out or calculate the total change in the oxidation number of both chromium and sulfur. So that can be calculated as, first we can take chromium. Total decrease, okay, or total change in the oxidation number of chromium. For that, first we need to calculate the total oxidation number of chromium here. Chromium, it has an oxidation number +3, but there are 2 chromium atoms, so 2 into +3, that is 6. Minus, come to the reactant side. Here, chromium has +6 charge or +6 oxidation state. So there are 2 chromium atoms or chromium ions. So +6 into 2, that is +12. So 6 minus 12, that is equal to 6. Now let's go to sulfur. We can start from the product side. Sulfur, the oxidation number is 6 minus, on the reactant side, the oxidation number of sulfur is 4. So 6 minus 4, that is equal to 2. Now we have got the total change in the oxidation number of chromium as well as sulfur. 6 and 2. But we have to equalize this total change. for both chromium and sulfur. Here, for chromium it is 6, for sulfur it is 2. Take their simplest ratio. Divide both 6 and 2 by 2. We will get 6 divided by 2, 3. Here it is 1. Now look, we need to equalize this. The total change in the oxidation number of chromium must be equal to the total change in the oxidation number of sulfur. So in order to equalize it, we need to multiply the sulfur part by the number 3. So wherever sulfur is there, on the reactant as well as on the product side, we can multiply by the coefficient 3. So here 3, here also 3. Now the biggest challenge is over, the oxidation number part. We can rewrite the equation once again. This time we can rewrite the equations without showing the oxidation numbers. Okay, you may think the balancing is over. No. This reaction takes place in the acid medium. So it is very important that we need to equalize or balance the ionic charge on the product as well as on the reactant side. So how can we balance the ionic charges? So remember the steps, children. First we have to write the equation correctly. We have assigned oxidation number. We identified the elements whose oxidation number changes, and then we balance the elements. Then we calculated the total change or the decrease or increase in the oxidation number of the elements whose oxidation number changes. And then next step is balance the ionic charges. In order to balance the ionic charges, if it is in the acid medium, we need to add H plus ions. If it is happening in the basic medium, if the reaction takes place in the basic medium, we need to add OH minus ions. So this is the next step, balance the ionic charges. So how can we balance ionic charges? Let's see. Here, all the 4 species are ions. Here, the charge of the ion is -2 plus. Here the charge of sulfide radical is 2 minus, but there are 3 sulfide radicals. So 3 into 2 minus, that is -6. So total it is -8. Now on the product side, we have chromium 3 plus, but there are 2 chromium 3 plus. So 3 plus into 2, that is +6. Now for sulfate radical, the charge is 2 minus, but there are 3 sulfate radicals. So 3 into 2 minus, that is -6. So total 0. So here it is 0, here it is -8. And the reaction occurs in the acid medium. So in order to balance the ionic charges on this side, on the reactant and on the product side, we need to add H plus ions. Where will you put H plus ions? Here or here? Here. Here there is a -8 charge. You can cancel it by adding 8 H plus ions. Okay? So here there are -8 charges. We can nullify it by adding 8H plus. Here you add this 8H plus. On the reactant side. Hope you understood this part. Now our last step is to balance the hydrogen or oxygen atoms. The hydrogen and oxygen atoms are always balanced at the end of the process. Okay. So, in order to balance hydrogen or oxygen atom, we need to add H2 molecules because this is taking place in the aqueous solution. So, now our question is, where will we add the H2 molecules? For that, we need to count the hydrogen atoms. Okay. On the reactant side, there are 8 H plus ions. So, there are 8 hydrogen ions. On the product side, there is no hydrogen ions. So, we need to add water molecules. In water molecules, already 2 hydrogen atoms are there. For 8 H plus, children, we need to take 4 water molecules. 4 twos are 8. Okay. So, by adding water molecules on appropriate side, we can balance hydrogen and oxygen atoms. Now you can also count the number of oxygen atoms, whether they are balanced. Here 7 oxygen atoms are there. Here 3 threes are 9 oxygen atoms. So total 16 oxygen atoms. Here 4 threes are 12 plus 4 oxygen, that is equal to 16. Oxygen atoms are also balanced. The equation is balanced.